Hello and welcome. We are working on lesson 2.2 and 2.3. This is day 2 of this topic. And today you can see we're really going to be focusing on approximations. So different methods approximating the derivatives. And just to recall, the derivative of a function tells us the rate of change of the function at a point. So it's all about this rate of change at a point. And I can't reiterate enough, if I have 2 points, I can calculate a slope. But if I only have 1 point, it's difficult to calculate a slope. So what we did is we allowed those 2 points to get very, very close together. So I had x and x plus h. And then this was as h went to 0. As h moves to 0, then this point is coming in closer and closer. And then I can draw in a tangent line and calculate the rate of change at a point. Oh, I'm sorry. Okay, sorry. Where were we at? I just got interrupted, sorry. Example 1, it says explain the meaning of f prime of 3 equals -7. Well, we know the prime symbol means derivatives. This must be some sort of rate of change. And it would mean the function, f of x, because they described it right there as f, is changing at a rate of -7 when x is 3. So that's how I would describe what that means. All right, approximating the derivative. There's a few different techniques. The derivative at a function tells us the rate or the slope of the tangent line, or the rate of change of the tangent line to that curve at a particular point. Sometimes we're not able to find the exact derivative, and in these cases we will approximate, or you could say we would estimate, the derivative using a difference quotient, or that slope calculation, y2 minus y1, and looking at it as AROC, the average rate of change. If you wanted to, you could even note this to yourself, y2 minus y1 over x2 minus x1, or if you think it's quicker, you can say rate of change of y over change of x. So what would these techniques look like? Well, if I had a table of values, I would use 2 points from that table and calculate the difference quotient. If I had a graph, I'd probably grab a ruler and try to draw in my tangent line and calculate out the slope, either by counting up and over when I hit nice grid points, those intersection points of grid lines, then I can count up and over. That would be one way of doing it. Or you could grab the 2 points and go back to the table of values idea, where we take 2 points and find the difference quotient. And then finally, if I have a calculator, a special one like our graphing calculators, it will calculate derivatives for us at a point. So we're going to go through how to do that as well in our lesson today. Approximating a derivative using tables. So this is where we said we would use 2 points and calculate a difference. So example 1, the function f of x, yep, I see that it's f of x, is continuous and differentiable for all x with selected values given above. Differentiable means it has a derivative at every point along the curve. There are some times where there are places not differentiable. That's coming in a future lesson, so hang on to that thought. But we also need continuity, and here we're guaranteed continuity, even though we only have a few selected values of x along our curve. If I wanted to approximate at 2, I'm going to go to my table and look for, where would 2 fall in? Well, 2 would fall in kind of between 1 and 3, right? So I'm going to use the ordered pair here and the ordered pair here as my 2 points to find a difference quotient. So I'm going to pick out the point 1, -2, and 3, 1, and I'm going to compute f prime of 2. Now this isn't an exact, so I'm going to use approximation symbol. And remember how this goes? Y minus y. So I'm going to go 1 minus -2. And then I must subtract my x's in that same direction. I started on the right, subtracting the 1 on the left. So there's my computation. I would end up with 3 over 2. So I'm estimating the slope to be 3/2. See if you can do the next one. Pause the video and give it a try. So here's my answer. I ended up with an answer of 1. And I took the difference of my y's, 5 minus 1. And I took the difference of the x's, 7 minus 3. As you can see up above in the table, those are the 2 points I selected because we were calculating the derivative at 5. Now, if you did not have anything on the left, count your problem wrong, because I don't know what your calculations were about. You have to have a left side to stuff in AP Calc. It tells the story, right? It tells me what 1 was. 1 was the derivative of f of 5. Okay, the next thing, what if we had a graph? Well, we've practiced a little bit with graphs, haven't we? So, use the graph of g of x above to approximate the following values. G prime of -2. So you're going to take your ruler and do your best job of estimating the slope at -2. And I wish my line was a little bit different color. Let's see if I can change that color real quick. Might not be able to get to it. It's not going to change for me. Darn it. Oh, but it did. Now, if this thing would go back, that'd be great. Not so much, huh? Not sure. Auto hide. There, went away. Okay. We did get a different thing in here. So, different color. What I would do is try to find some nice points. And maybe -2, 0. And perhaps, where's another one? I don't have any other real nice ones. 1, 2, 3. I'm thinking maybe up here that it's going through about a half. It's an approximation, you know? So it's about the best we can do. I'm going to call that, what would that be, like -1.5, comma, 5. And then I can go 5 minus 0 over -1.5, take away -2, which will turn out to be a plus. Let me move this up a little bit. I had -1.5 minus -2, so that became a plus. That gives me 5 over a half, and that's like 5 times a 2 over 1. I'm getting a slope of 10. I knew it was steep, and it should be positive, so I'm liking that. Let's move on to g of -1, all right? Get your ruler out. Do your best job of estimating this tangent line. Just move that tangent one off. See if I can get a different one on here. At -1, so I want to be tangent to that. Kind of estimating with my eyes. Something like that. Oh gosh, these are hard, aren't they? Because we're just not hitting super nice points. But if I used -1 and maybe 4, it's not quite 5, is it? Maybe 4.8. That's my estimate. And then, what's another nice, decent point? I think I'm going to go after this one right here. And that would be what? At -2, 3.8? Close enough. Then I'm going to go 4.8, difference of my y's over the difference of my x's. And what would I end up with? Did I grab? Oh, I did. I'm going to come out with a negative. I started at the top. I need to start at the top of my x's. -1 minus -2. I knew I should have a positive slope. So there I get my +1 on the bottom I was after. and it looks like I have a 1.0 change on top, I would call that slope roughly 1. Keep in mind, we're doing estimates. And then finally, g of 1. So draw in your line, g of 1. Where is that at? Right there. Get your best tangent line at that point. It's hard to decide whether I want to be on the front side of that or the back side of that. Not bad there. I think I can live with that. Somewhere, just wanted it to touch at my point. Now, oh, I like this grid point, and might as well use this grid point. So I'm going to use a 1, 0 and a 0, 3. I can already see what this could be. Can you? 3 minus 0. See, I have to use arrows because it just keeps me moving in the same direction, which is what you have to have on that difference quotient. So 3 over negative 1, I'm getting a slope of negative 3. I like it. All right, and finally, there's 1 underneath my little symbols here. G prime of 0. G prime of 0. Well, then we want to go to 0. Where's 0? Right there. Draw in our tangent line. I don't like my tangent line. I gotta adjust. So I gotta adjust just a touch. Yeah, that looks a little closer, doesn't it? Okay, so what points do we want to use? I'm digging this one, 1, 1. Any others that you're really liking? Not so much, huh? Okay, I'm going to name this one then as 0, 3.7. And then I'm going to, maybe I'll put them down here by us. 0, 3.7, and a 1, 1. Difference of our y's. Difference of our y's. 3.7 minus 1 over difference of my x's, 0 minus 1, gets me a 2.6 over negative 1. Was it a negative slope? I can't see my picture. Yes, it was a negative slope, so I'm getting about 2.6. You know, there's not one exact answer, but we came close. For next question, for which values of x is g prime of x 0? So imagine to yourself what line has a slope of 0. Oh, that's right. Horizontal tangent lines have slopes of 0. Where on our picture would you encounter a slope of 0? Right there. And where's the other one? Right there. The max and the min, actually, right? Clever. So I'm going to say at x equals, it's just slightly bigger than 2, so I'm going to call it 2.1. In this one, it looks like we're 4/5 of the way. How about x equals negative 0.8? Seems reasonable. Next question. Approximating, put the following values in order from least to greatest. So we've got g prime of 0, g prime of negative 2, and g prime of 2. Well, up above, we did some calculating, didn't we? G prime of 0, we calculated out to be like negative, was it about 2.5 or 2.6 or something like that? I can't quite remember. I'd have to stretch back. And then g prime of negative 2, we did that one. Came up with 10. Oh, that one had a big slope to it, didn't it? And then g of 2 we didn't do, so I've got to go look at that one. G prime of 2. Oh, well, that's got a slope of 0. I can figure that out. So g prime of 0, that had that negative slope. G prime of negative 2 had a positive slope, positive, negative, and 0. Well, that's pretty easy then to organize order. I would have my negative slope first, which was occurring at g prime of 0. That slope is less than g prime of 2, which had the 0 slope, which was less than the positive slope, which occurred at g prime of -2. See if you can do the next two on your own. I would just encourage you to probably go to the graph, draw in simple little tangent lines, and then organize your thoughts from there. Okay, so the middle one, here's how I thought this went through. I drew in my tangent lines at those three spots, looked at their slopes, and some of them we had calculated out prior, like these two. You know, where this one was roughly -3.3 or something like that we came in. So my least is going to be the -3. The next one at g prime of 0 was -2.5, and then I had the 0 slope. Okay? And for C, let me just look at my notes how I had this one organized. I had g prime of 1 less than g prime of -1 less than g prime of 3. So take a look at those individual slopes, and that's the way it should organize. Moving on, this is going to be the calculator work. So grab your calculator. Here is our function, maybe highlight it, box it out. We're going to find h prime of -1, h of 0, I'm sorry, h prime of 0, h of 4, h prime. Oh, so this one doesn't have a prime symbol. That'll be interesting, right? That should be the easiest one for us to do because we've done stuff like that before. Now, because I'm going to be using this over and over again, I'll show you two different methods. Where can I put this out? Say, all right. Oh, that helped, didn't it? All right, get over here. It just won't do it. Okay. Let me write down that function. H of x was natural log of x cubed plus 11. There we go. So if you look at your directions, I do give you a couple of ways to get to derivative. Alpha, the green key. Window, option number 3 says n derivative. So that gets you to there. Then you can key in dx. You can put your function right here, natural log of x raised to the 3rd, bounce over using your arrow key, and then plus 11. We want to evaluate this at -1. So we'll just put in -1, boom, we have our answer. In AP Calculus, you must have 3 decimal points. So we're going to go h prime of -1 equals 0.300. I guess with the 0 zeros, I'm going to go ahead and put it down. That way, in my mind, I know I've covered it to 3 decimal places. Would I actually need them on the AP test? Not if it's not if it's 0 following that 0.3. But I think it's just a good habit to do. All right. Now, a quick way, if I'm still using the same function, I could do a copy and paste. So I arrowed up, highlighted it, grabbed it, and now I can just go in and edit. So I'm going to switch that to a 0, boom. Ooh, this is very, very small, isn't it? I'm going to do this one more time. I see that it says -0, which is a little weird. I'm kind of surprised it actually even calculated. Okay, we did get the same answer. E to the -8. Well, that tells me then that this is basically a slope of 0, doesn't it? H prime of 0 is 0. And for that, I'm not going to put the decimals after it. Kind of countering myself, aren't I? Okay. H of 4. Well, I can't really copy and paste because I don't want to do a derivative. Maybe make a note to yourself. No derivative. I just want to know what the function evaluated at 4 is. Well, I could take 4 and cube it, so h of 4 would look like natural log of 4 cubed plus 11, which would give me natural log of what, 64 and 11, 64 and 11, 75. And then I could get that. So I could just go natural log, 75, boom. And we've got an answer of 4.317. The other way that I want to show you to do this is if it's a function I'm going to be using repeatedly, I could go to y equals and just key in the basic function. Oops, get a plus sign in there. Not 0, 0. Watch my fingers. Okay. We've got our function in. Then I'm going to go to the home page. How do you get to home page? Second quit. Now, I'm going to recall my function. I had this in y1. So I'm going to go alpha trace, which gives me my y variables. And y1, parenthesis that with a 4, close it. The reason I'm choosing 4 is because I'm evaluating y1 at 4. And there's that same number. So now we're coming into h prime of 5.1. Well, I've got it stored in y1, so I'm going to make use of that. Another option besides alpha window option 3 is math option 8. So depending on where you like to look at it, suit yourself which method you use to find the derivative. I'm going to go d dx. I'm going to grab my y1, not second, but alpha, trace, option 1 there, and then evaluating it at, well, we wanted to evaluate at 5.1. And there's our answer. So format your answer with an h prime of 5.1 equals 0.543. Using a calculator is fun, isn't it? Way faster than doing all the long methods. Find the following values at the ones shown. So this you can do on your own and then come back. I would load this as my y1 or my y2. Okay? All right, here are my answers. Hopefully you got the same. You can freeze the screen if you need to. Notice on the end here I've given 2 answers, and that is because the AP allows you to round the answer. It was like negative 0.1799, blah, 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 blah. And so I could round that to 1.80, or I can just cut things off and just write the first 3 decimals, which is called truncating. So they accept either method. Either of those answers would be perfectly fine. Here is my calculator work. You can see at -2, at pi, at e squared, and my other one's not showing on the screen. All right, you have homework, and it is the worksheet here. I think we've gone through all the techniques. Good luck.